All right, let's take a look at using synthetic division to divide f of x equal x cubed plus 18x squared plus 101x plus 180 by x plus 4. And we want to use the result to find all zeros of f. So remember, when we do synthetic division, we have to think of our divisor as x minus c. So x plus 4 is x minus negative 4. So our c is negative 4, which goes in this position. Now we write the coefficients of f of x, 1, 18, 101, and 180. So 1 is the coefficient of x squared, 18 is the coefficient of x cubed, 18 is the coefficient of x squared, 101 is the coefficient of x, and 180 is the constant. We make sure there are no missing powers of x. If there were, we would fill them in with zero coefficients. We bring down the first coefficient, multiply that by negative 4, we get negative 4. Add that to 18 to get 14. Multiply 14 by negative 4 and get negative 56. Add that to 101 and we get 45. Multiplying 45 by negative 4 gives us negative 180. Adding that to the coefficient 180 gives us 0. And 0 is our remainder, which tells us x plus 4, which is what we were dividing by, is a factor of f of x. So f of x equals x plus 4 times our quotient, x squared plus 14x plus 45, which is given to us by the bottom line of the synthetic division. So the 1 is the coefficient of x squared, 14 is the coefficient of x, 45 is our constant. So notice the quotient comes from these parts of these numbers in this part of synthetic division. The 0 is our remainder. When 0 is a remainder, it means what we were dividing by is a factor of what we were dividing into. Now I can factor the x squared plus 14x plus 45 into x plus 9 times x plus 5. When I set f of x equal to 0, I'm finding the zeros of the function. So if x plus 4 is 0, x is negative 4. If x plus 9 is 0, x is negative 9. If x plus 5 is 0, x is negative 5. These are the zeros of my function. And it's important to remember that when you use synthetic division and get a 0 remainder, that indicates that you have divided by a factor. Since this is a third degree polynomial, it's going to have 3 zeros, even if some of those zeros are repeated zeros. So x equal negative 4, x equal negative 9, and x equal to negative 5 are the zeros of our polynomial f of x.